In this video, we're going to go through the questions that were from the April 2021 math section of the ACT, and I'm going to go through and work each of these problems. I'll share a few tips with some of these and maybe even alternative ways that you could answer the questions, things that you want to look for when you're working an ACT test. As we begin each question, you're going to see at the bottom of the screen the major topic that you're being tested on in that particular question. And if you have any questions about that topic, I would encourage you to go to my YouTube channel. You can get to that through my website at teachmathwithme.com. I have more videos that go into more detail on each of the major topics that we find on the ACT, and you can find that there on my YouTube channel. Question number 1 states that the first term in the geometric sequence below is negative 13. If it can be determined, what is the 6th term? And we're given 5 terms here, and we're looking for the 6th term. So we have a clue in our wording that this is a geometric sequence, a sequence being a pattern to go from negative 13 to 26 to negative 52. We want to find what that pattern is, and because it's geometric, we know that we're going to get that by multiplying or dividing by a number from one number to get to the next number. And so if we'll take a look here, we can see where one pattern is a negative, positive, negative, positive, negative. So we know the 6th term is going to be a positive value. And so we can already eliminate choices A and B. And we need to find what that value that we're multiplying by. To go from negative 13 to 26, we're going to multiply by negative 2. And you can just check to go from 26 to negative 52, you multiply by negative 2. So in turn, we're going to find that to find that 6th term, we're going to multiply by negative 2, and that's going to be a positive 416, which is answer choice D. Question 2 says, in the standard XY coordinate plane, point A has coordinates negative 7, negative 5, and point A is translated 7 units to the left and 5 units down, and that image is labeled A prime. What are the coordinates of A prime? So we're looking for A prime given that we have the point A, which is negative 7, 5, and we're going to do some translations here. It says it's translated 7 units to the left. So when we're talking about going left or right, that's going to be a change to the X coordinate. And 7 units left is going to mean in a negative direction. So instead of being at the point negative 7, we're going to go 7 units to the left. So we're going to subtract 7 units, and we have a negative 14 for our X value. Now, as you're answering questions, one hint or one strategy that you need to be doing is all along you're glancing at the answer choices. And as we can already see, when we do this translation 7 units to the left, and the other translation is 5 units down, that's going to be a modification to the Y coordinate. So we're not changing the X coordinate anymore. We know that the X coordinate of A prime is negative 14. When we look at our answer choices, there's only one option for an answer with an X value of negative 14, and that's answer choice F. So we already can put the answer down and stop right here. But let's go ahead. We'll finish out this problem, but you do not have to do this when you're taking the actual test. Get the answer. You may not have to answer a question all the way to completion before you can find what that correct answer choice is. So if we do 5 units down, we said that's a change in the Y coordinates. 5 units down is going to be in the negative direction. So negative 5 from this Y coordinate, negative 5 minus 5 gives us a negative 10, and that does confirm that that point is F, negative 14, negative 10 for A prime. For question number 3, we're told that Olga worked on a project for 4.5 hours on each of 6 days. On the 7th day of working on the project, Olga worked 1/3 of the time she had worked each of the previous work days to complete the project. How many hours did it take Olga to complete the project? So we're looking at using some fractions here, and we know that for 6 days she worked 4.5 hours. And then on the 7th day of the project, she worked 1/3 of the time she had worked each of the previous days. So each day she worked 4.5 hours, so she's only going to work 1/3 of 4.5. Now, there's multiple ways you can work most problems, and the same here. We have a fraction. You can put fractions into your calculator, or you can work them out by hand. I'm going to work this out by hand. It's easier for me to do that. I'm going to change this 4.5 into an improper fraction, which is 9/2, and I'm going to do some simplifying, and I get 27 hours for those first 6 days, and then 1/3 of 9/2 is 9/6, which is 3/2 or 1 1/2. And we want to know how many hours in the total days. So 27 plus 1 1/2 gives us 28 1/2 hours for the entire project, and that's answer choice B. Question number 4 says, given that 5 pounds of coffee makes exactly 210 servings, how many pounds of coffee makes exactly 70 servings? So this question is setting us up to use a proportion. So we know 5 pounds provides 210 servings, and we can set that up to an equivalent statement. We don't know how many pounds, that's our unknown, gives us 70 servings. And so now we have this equal proportion. We can crisscross and multiply, and that means we take the 5 times 70 is equal to 210 times x. We're going to get 350 equals 210x. We'll divide both sides by 210, and we'll get an answer over here that x is equal to, you can put that in your calculator or do it here by hand. We've got 7 that goes into both of those numbers, 5/3, which equals 1 2/3 as a mixed number, and that is answer choice F. Question number 5, we're told for line RT, shown below, point S is on segment RT. The length of segment RS is 10 centimeters, and the length of ST, the segment, is 18 centimeters. What is the distance in centimeters between T and the midpoint of the line segment RS? So we've got these values labeled that they tell us here, so that's nice. We don't have to worry about it. Let's get to the meat of the question. They want to know the distance. We're in centimeters. Everything's in centimeters. Units look good. What is the distance between T, so we're talking about T here, and the midpoint of RS? We need to know what midpoint is, mid being the middle between this segment RS, and RS is right here, and we're looking for the midpoint. That's going to divide this 10 into 2. We're going to have 5 on one side and 5 on the other. So we're looking for the distance right here between that midpoint and T. That's the length. And we know the length from S to T is 18, and we know the length we just found from the midpoint of the middle point to S is 5, so we're going to add 18 plus 5, and that equals 23, which is answer choice D. Question 6 says, for all real values of P and R, which of the following expressions is equivalent to this expression here? So we're going to, it looks like, simplify. When I'm looking at my answer choices, I see it looks like we've done some combining of like terms. We've done some distributing, and then we'll have to combine those terms to get this final value. So let's work on first distributing this P through the 2 minus R, and we get 2P minus PR, and now we'll distribute the 8 through P minus R, 8P minus 8R. Now we can clean this up a little bit by combining like terms, and we notice we have both a 2P and an 8P. 2P plus 8P, that gives us 10P. Then we have this minus PR minus 8R. Those are 2 different terms. We have PR, 2 variables here, and then a coefficient 8 and 1 variable R. So we can't combine those anymore. We can just rewrite that as minus PR minus 8R. So when we glance at our answer choices, we see the only one that fits for that is answer choice K. They wrote it a little differently with the minus 8R minus PR, because we can do that. We can flip those around. That's the same thing, these 2 answers. So we have answer choice K. Question 7 tells us that 50 shoppers at a pet store were asked if they owned at least one cat or at least one dog. Data from their answers were recorded below. So we have this table, this chart here. How many of these shoppers said that they owned neither a cat nor a dog? So they don't own a cat and they don't own a dog. Well, let's look at the data that we're given. I like to put this data in something like a Venn diagram. And that shows us the two different categories that we have. We can either have cats or dogs or own both, or we can have neither. This includes our entire data set within this square value. So we have those that own cats only are 13, those that only own dogs are 24, and both cats and dog are 7 in this intersection value. So we want to add up all these numbers, this 13 plus 24 plus 7, and we should get 44. But remember, there were 50 total shoppers. So 50 minus 44 is going to give us 6 outside owning cats and dogs that don't own, they own neither a cat nor a dog. And that's answer choice B. Again, the Venn diagram is not necessary, but it may just give you a better feel for if the question was a little bit more complex, or if you were even given a Venn diagram to know how to use it. But it helps us to visualize our chart data, what they're actually talking about. Question number 8 says Yvette has 6 pairs of leggings, 2 pairs of shoes, and 6 t-shirts, which all go together well. How many different groupings consisting of one of her 6 pairs of leggings, one of her 2 pairs of shoes, and one of her 6 t-shirts are available for her to wear? So we know that we have 6 pairs of leggings, 2 pairs of shoes, and 6 t-shirts. This is a counting problem. When we have multiple ways to do different things and we're going to choose one of each, we're just going to multiply those together. The 6 times 2 times 6, and that gives us 72, which is answer choice K. We just multiply those different options. Question 9 says, according to the United States Department of Commerce, the approximate area of Rhode Island is 1.5 times 10 to the third square miles, and the approximate area of Alaska is 6.6 times 10 to the fifth square miles. Using these measurements, which of the following is closest to the ratio of the area of Alaska to the area of Rhode Island? So we're setting up this ratio, and if you'll notice from your answer choices, we're going to be making use of the colon to define this ratio, and we're doing the area of Alaska to the area of Rhode Island. That's important, the order that we're setting up the ratio. And they give us these values in scientific notation, but the reason I say that order is important is because notice they gave us Rhode Island first up here and then Alaska. So we want to make sure we match those up appropriately. So the area of Alaska is the 6.6 times 10 to the fifth, a large number, a really large number, larger than Rhode Island, which is the 1.5 times 10 to the third. We have the 10 to the fifth versus the 10 to the third. And in general, if you know much about geography, you know Alaska is a larger state than Rhode Island. So we're just also spot checking things. We're not just blindly using these numbers. We're using a little bit of outside knowledge to make sure this looks correct. This is a valid ratio right here, but when we look at our choices, we see none of these choices make use of scientific notation. So we need to do some reducing. Just like we can reduce a fraction, 3/6, we know we can reduce that to 1/2. You can do the same things with ratios. I could set up a ratio of 3 to 6 and rewrite that as a 1 to 2 ratio. I can reduce a ratio in this form just as I can in a fractional form. So let's try to do the same here. And the first thing that I'm going to do is I'm going to take the smaller number, the 1.5 times 10 to the third, and let's see if we can divide that into the 6.6 times 10 to the fifth. So when you do this division, if you do the division with scientific notation in your calculator, you may get 4.4 times 10 to the second power to 1, because that divides into 1. Now, again, our answers are not in scientific notation, but we can convert this 4.4 from scientific notation into a standard form of a number. Remember, 10 to the second means that we move the decimal point 2 places to the right. So we're going to add a 0 here on the end. That will make it 440 to 1, and that is answer choice B. Depending on your calculator, it may have given you this as the answer, or you may have had to do the conversion. Question 10 says that rectangle A has a length of 64 inches and a width of 48 inches. So we'll say rectangle 8 is a 64 by 48. Rectangle B has a length and width that are both 3/4 times the length and width of rectangle A. So it's going to be 3/4 of 64 by 3/4 of 48 for rectangle B. And then rectangle C has a length and width that are both 3/4 the length and width of rectangle B. So I'm just going to say 3/4 of B. And we'll use that information here. When we look at our question, what are we ultimately being asked? What is the perimeter in inches of rectangle C? So first thing I always just like to glance and make sure of is that my units are okay. We're asked for perimeter in inches, and yes, we're given these values of length and width in inches, so we're good. So we ultimately have to find perimeter of rectangle C. And let's remind ourselves, how do we find the perimeter of a rectangle? We're going to say for rectangle C, it's going to be 2 times the length of rectangle C plus 2 times the width of rectangle C. That's a formula we need to be familiar with. 2L plus 2W for a rectangle. Now, we don't know the exact values, though. We're going to have to kind of work backwards. So we have this value. We know it's the length and width is 3/4 that of B. So we need to find what the length and width of rectangle B is. So we have this 3/4 times 64. You can put this in your calculator and do some simplifying, but this turns out to be 3 times 16, which is 48, by, and when I do the same over here, some simplifying, a 48 by 36 for B. And we know that C is 3/4 of that, so it's 3/4 of 48 by 3/4 of 36. And we can do our simplifying again, and that is a 36 by 27. So that is our measurements for rectangle C. We can plug that into our formula for perimeter of rectangle C. So we have 2 times 36 plus 2 times 27, and you can put that into your calculator, and you get 72 plus 54, which turns out to be 126, which is answer choice H. Question 11, they are asking us to basically simplify the expression x to the 6th raised to the 3rd. It is equivalent to what? And so what we're going to do when we have a variable raised to an exponent raised to a power, what do we do with these values of 6 and 3? Well, just remember that this is the same as x to the 6th times x to the 6th times x to the 6th, and when we multiply variables of the same base, we add the exponents. That's the same as x to the 6th plus 6 plus 6, which is equal to x to 3 times 6 is another way to write it, which is x to the 18th. That is our answer. It's going to be B choice, x to the 18th. But then, because we know how we've derived this, we can also just look at x to the 6th raised to the 3rd, as we can go straight to this step right here. It's just multiplying these two numbers together, giving us x to the 18th. Question 12 says a king-sized inflatable rectangular bed, when fully inflated, will have inside dimensions in inches of 78 by 75 by 5. An air pump can pump air into the bed at a rate of 100 cubic inches. I'm just looking at my units per second. At that rate, which of the following is closest to the number of seconds it will take to fully inflate the bed? So we have a rectangular unit here that is 78 by 75 by 5, and we're given a rate of 100 cubic inches per second. How many seconds to inflate this? We know each of these are in inches. Our units look good, and our answer is in seconds, so that's nice. So what about if we find the volume of this rectangular surface? Remember, that's length times width times height. We'll just multiply the 78 by 75 by 5, and we get a value of 29,250 cubic inches. And then we're going to take this value and divide through by the 100 cubic inches per second. Remember, when we put a value in the denominator and it's in the denominator of that denominator, it flips and our unit's going to actually be in seconds, and we get as an answer 292.5 seconds. And our clue is it's which one is closest to. We're going to do a little rounding. That rounds up to 293 seconds, which is really the only close answer in here, answer choice J. Question 13 says Jake wants to build a scale model of his house. The house is 48 feet long and 32 feet wide, and it is 30 feet tall at the highest point. Jake wants the model to be 8 inches long, so we're doing a scale model. How wide in inches should his model be? So this is going to be, since we're doing a scale model, the model is going to be in proportion to the actual house. The smaller models in proportion. So the actual house itself, let's just do a quick drawing here. Something maybe just a quick thing of this house. We know that it is 48 feet long, it is 32 feet wide, and 30 feet tall at the highest point. That's not really an actual drawing to scale, but that's the one that'll help us visualize it. Now, when we do our scaled model, we are given that of the smaller scale model, 8 inches in length is what they want for the length. So then the question turns out to be, how wide should this model be? So that's our unknown, is the X. So anytime we're doing a scale model and we're doing these in proportion, we want to match up with values that we are given. And we are given this value of 8 for the length, so we're going to make use of the actual, the 48. So we know that the 48 of the full size house goes with 8 of the scale model. And now we want to match up. We're using X, we're looking for X, the width. So we match that up also with the length of the scaled model, and we're going to make use of the actual length of the house, and that will go in the numerator too, because I used in the numerator for what we were given, that of the house. So when we set up a proportion like this, like we did in I believe it was the first or second problem, we can crisscross here and multiply, and we'll get that 48x equals 32 times 8, and we're going to have 48x is equal to 256. We'll divide both sides by 48, and we get that x is equal to 5 1/3, and that is answer choice B. That's going to be the scaled model, the width. Let's take a look at question 14. It says you see a circle graph in a newspaper article about student employee. No percentages are given for the sectors. You want to use the information contained in the graph in a report. You measure the central angle of the sector titled work during the week with your protractor, and it measures 144 degrees. According to the circle graph and your measurement, the work during the week sector is what percent to the nearest percent of the circle graph. So remember, when we have a circle, the full degrees in a circle is 360 degrees. And for whatever this article, it makes use of the circle graph, it's saying that for the work during the week, it turns out to be something like 144 degrees for that measurement for the work during the week, and we want to know what percent of the total circle that is. Well, then we're going to take the 144, divide that by 360, and when you put that in your calculator, you should get 0.4, but we're looking for our answers in percent, and 0.4 is the same as 40%, which is answer choice F. Question 15 says Josiah stands on level ground 15 feet from the base of a cliff. That's labeled here. The angle of elevation from where Josiah is standing to the top of the cliff is 50. They've given us that there. Which of the following values is closest to the height in feet of the cliff? So we're looking for this unknown value h. And notice they give us a note here where they tell us the values of sine of 50, cosine 50, and tangent 50. So this is a trig question where we're probably going to make use of these trig functions here. Now, we want to know, remember, as a reminder, they've already got this labeled, but it's always good to remember angle of elevation. That is the angle made there with the horizontal. So is this, as this person is looking up and we're looking to the top of the cliff, that's a 50-degree angle. So they've drawn this particular one to be from his feet, and this is their graph. We'll use that. So we're looking for h, and what we want to make use of is the values that we're given. We're given an angle, and we're given a length of this right triangle that we're found here. So we know with our trig functions, we need to make use of opposite, adjacent, hypotenuse, that sort of thing. As a reminder, we know that the side length opposite the right angle is your hypotenuse. It is your longest side length. We're not asked for anything in this particular question on that yet. We know that let's look at this 15. Relative to the 50-degree angle, this is the adjacent side length. And relative again to the 50 degree, what we're looking for, this H, this is the opposite side length. So if we're looking for the opposite and we have the adjacent, we need to know which trig function we're going to make use of. Opposite and adjacent, that's going to be our tangent trig function. So we take tangent of 50 degrees is equal to h, our opposite, which is our unknown, over 15, what we're given. And we want to solve for h, so I'm going to multiply both sides by 15, and I get that h is equal to 15 tangent 50. And this is nice. We could have plugged tangent 50 in our calculator, but they've given it to us. They say it's approximately 1.2. So I'm going to plug in 1.2 for tangent 50, put that into my calculator, and you should get that h is equal to 18, which is answer choice C. Question 16 asks us to consider the line 3x minus 4y equals 6 in the standard xy coordinate plane. For the point on this line with x coordinate equal to 3, what is the y coordinate? So this is worded, it may seem a little wordy, but all they're really asking you to do is plug in a value of 3 for x, and then we're going to solve for y in this equation. So we get that 9 minus 4y is equal to 6. We're solving for y, so I'm going to subtract 9 from both sides, divide through by negative 4, and I get that y is equal to negative 3 over negative 4, which is really just 3 over 4, and that is answer choice H. Question 17 says, what is the solution set to the equation x squared minus x equals 12? Solution set, don't let those words confuse you. If you glance at your answer choices, you see that we're just looking for values that solve this equation, x squared minus x. To solve a quadratic, which is what this is when it's raised to the second power, I want to put everything on one side and set that equal to 0, and I get that by subtracting 12 from both sides. Set that equal to 0. Now I have a couple of different ways I can work this problem, and it's whatever's most comfortable for you. The first thing I tend to do is when I have a quadratic, I'm going to try to factor. And so I'm going to set this up with my two factored forms. I'm going to look at the sign of the number in front of the whole number coefficient, and it's a negative sign, a minus. That means my signs are going to be different. And then I look at the sign in between the x squared and the x. It's a negative. That means the larger number is going to be a negative. So signs are different. One's going to be a negative. One's going to be a positive. Now I need to look at what numbers do I multiply together to get 12 and add to get, this is a 1 in front of this, an understood 1. So multiply to get a 12, subtract to get a 1. And so when I do that, when I think of multiplying to get 12, I'm going to think about 4 and 3 because their difference is 1. So 4 is in front of the negative, the larger number, and then a positive 3. We set these equal to 0 to find what these values are. X equal to 4 and x equals to a negative 3. And that turns out to be answer choice B, where we have the solution set negative 3, positive 4. Another way you could have solved this problem, if you weren't very comfortable with factoring, is you could have taken these different values, these solution sets, and plugged in the values for x. And if you got, when you plug in like a negative 4 equal to x, if it's equal to 12, that would have been the answer, but you would have seen that that didn't work, so you would have eliminated answer choice A. Then you would tried for the values in B, and you would have found those to be correct. But that process, it's just dependent on where the answer is in the choices, A through E, and where you begin by plugging in. But that is another way that you could solve this question. Question 18 says the vertices of triangle PQR are given in the standard XY coordinate plane below, and they are labeled here. We have PQ and R labeled. What is the area in square coordinate units of triangle PQR? So we've got to know how to find the area of a triangle, and that's equal to 1/2 base times height. So we need to know what our base is and what our height is. And when we're given this triangle here with the coordinate units, we can figure out all of those things. When I'm looking at this triangle, what looks easiest to me to use as a base is this length right here, represented from P to R. So I can find the length of this base by looking at the change in the y values from P to R. And we go from an 11 to 3. So our base is going to be equal to 11 minus 3, which is equal to 8. So that gives us, we'll go ahead and fill in 1/2 times 8. Now what about our height? If this is our base, our height will be right here. And you may say, well, I don't know what H is. Well, we can look at that. That is the difference between this point here. I can figure out what this is, but the difference is along the X, the change in X. And we know this point has a value of 5. Any point along this line has an X value of 5 to Q, which has a value of 8. So H is going to be the difference between 8 and 5. 8 minus 5, which gives us 3. So our value for H for height is 3. We can simplify here and we get to 4 times 3, which is 12, and that is answer choice H for the area. Anytime you have a question here with coordinate units and you're looking for measurements, make sure you can do some drawing, you can look at the numbers, see how they simplify, any kind of manipulation that you can do with what the values you're given. They have given you everything you need to answer this question set up here, either in the problem description or in the figure itself. And that's how it's going to be for other questions. Question 19, in the standard XY coordinate plane, a line intersects the y-axis at 0, 2 and contains the point 8, 5. What is the slope of the line? So we're looking for slope, and if you remember, we often use M to represent slope, and by definition, slope is the change in Y over the change in X, or you may have seen the formula Y2 minus Y1 over X2 minus X1. And we're going to make use of this because we have 2 points. We have the point 0, 2, which we can use as x1 and y1, and the point 8, 5 we'll say is x2 and y2. And we're just going to plug those values in. So the change in y goes from a 5 to a 2, so 5 minus 2, we're subtracting, and x2 is 8 minus the x1 value of 0. And so we'll just subtract here. 5 minus 2 is 3 over 8. That gives us a slope of 3/8. Now let's say you had a problem remembering exactly what this formula is. Another thing you can do when you have points, try to plot them on a coordinate plane that you draw yourself. You have the point 0, 2, which is about right here, and then we have the point 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. And 8, 5. So that goes about right there. So we know this is what we're really talking about, is a line that passes through those 2 points, and we want to know the slope. Well, one thing that we recognize first that I always like to look at with slope is it positive or negative? And we figure that out by looking, just like we read from left to right, we look at our graph, and from left to right, this line is increasing. It's going in a positive direction. Versus if you had a line that did something like that, from left to right, it's going in a negative direction. This line has a negative slope. Well, when we look at our answer choices here, all of these are positive, so we really can't eliminate yet based on that. But then another thing that from a graph you might be familiar with is when we look at rise over run. So if we start at our 1 point here and we see how much do we rise, we go up 1, 2, 3, we rise 3, and we go across, we run 8. And so that gives us a rise over run of 3/8, which turns out to be answer choice A again. That is correct. This is the same thing we're doing when we use the formula. We're just doing it more in a graphical form. Let's look at question 20. One of the following values for A makes the expression 2a plus 5 over a squared plus 1 undefined. Which one? So what we need to think about is what makes an expression undefined. And when we are given this 2a plus 5 over a squared plus 1, one thing you should always think about when you're either looking at the domain, that is one area where we look at things being undefined, or even asymptotes. That's another thing where this area might come into play. When we have a fraction, a rational expression, we're going to look at the denominator. And we know that we cannot have where the denominator is equal to 0. We can't have 0 in the denominator. So we're going to look at setting this equal to 0, and we get a squared equals to -1. And you might be getting a little concerned at this point because we know to get rid of a square, we're going to take the square root, and we get a square root of a -1. Hopefully, though, you've had some experience with now taking the square root of a negative number, and we know that the square root of a -1 is equal to I, the imaginary number, and that is one of our answer choices, K. So this expression is going to be undefined when A is equal to I. Question 21 says, what is the least positive number that has a remainder of 3 when divided by 5 and a remainder of 7 when divided by 9? So we're looking for the least positive number. We're going to have to make use of our answer choices to determine here. And let's look at the conditions that we're looking for. When we divide through by 5, we want to have a remainder of 3. And when we divide through by 9, we want to have a remainder of 7. So because we're, like I said, looking for the least positive, I'm going to start with the smaller number. And in general, answer choices are given A through E from the least to the greatest. But it could vary. Sometimes they give us the greatest to the least. But since we're looking for least positive, I want to start with my smaller number and work my way up. So when I take 24 and I divide it by 5, I'm going to get a remainder of 4, and that does not satisfy that first condition. So A choice is out. Looking at 35, when I divide that by 5, well, that's an even number. That equals 7. I have a remainder of 0, so that doesn't work. 43, when I divide by 5, it has a remainder of 3, so that does meet the first condition. Now, what about when I take 43 and I divide that by 9? That equals to what? 4 with a remainder of 7. And so that does meet that condition. That's the first one, the smallest one. So 21 is going to be answer choice C, 43. You have to just work through each of those answer choices until you come upon the first correct answer. 22 says 2 warning signs begin flashing at the same time. So we'll have 1 and 2 that occur at the same time. One sign flashes every 3 seconds. And the other sign flashes every 8 seconds. How many seconds elapse from the moment the 2 signs flash at the same time until they next flash at the same time? So we have seen similar questions like this on other tests. One thing I always encourage students to do is take a lot of practice tests. The more questions, ACT type questions that you work, you're going to be familiar and you're going to know about what question that this particular one is coming to, even before you even get to the meat of the question. When I'm hearing about things occurring at the same time and then they occur at a different rate, this is going to actually be making use of least common multiple. Because what we're looking at here for these particular warning signs, they occur at the same time, and this one occurs every 3 seconds. So it's going to be at time 3, 6, 9, 12, 15, 18, 21, 24, 27, and on and on and on. We could continue on, right? We're doing multiples of 3. The second light flashes every 8 seconds. So that's at 8, 16, 24, 32, and on and on and on. Our question is asking if they first flash together at time 0 at the same time, when will they flash again at the same time? So we're looking for when our value is going to be the same. And we have a match, the least match, the first one we run into is at 24 seconds. After time 0, they will flash again at the same time at 24 seconds, which is answer choice K. Question 23 is giving us 3 sets, A, B, and C, and they give us the definition there. And they say that a number will be randomly selected from set A. What is the probability that the selected number will be an element of set B and an element of set C? So we're going to choose from set A, and we want to know what's the probability that that number is both in B and C. And is important here. And we're looking for probability. So I like to think of probability as part over the whole. So our entire data set. So we're going to have it in a fraction, as you can tell from the answer choices, or it could be 0. We want to look at how many, first our denominator is how many choices do we have for picking from set A. Well, we have 1, 2, 3, 4, 5, 6 numbers. So there's 6 numbers we can choose from. But then how many meet the condition that we're talking about that are in set B and C and also in A? So what makes sense to me when we look at sets B and C, we've got to find which, if any, values are both in B and C. And the only option for that is 2. And we confirm that 2 is an item in A because that is, we're making sure that when we choose from A, we're going to get something that's in B and C as well. So only one of the choices, 2, is in set B and C as well as in A. So we only have a probability of 1/6 choosing that, and that is answer choice B. Question 24 says, what rational number is exactly halfway between the fractions 3/16 and 7/32 on the real number line? So we're looking for a rational number that just tells us that it's a fraction, or that can be represented as a fraction, between 3/16. Exactly halfway is our clue. We're going to look really for the middle number there, the middle fraction, and we can take our 3/16 and 7/32, add them up, and divide by 2. That's going to give us that value. So you can do that in your calculator, or these are not very difficult fractions to work with. We want to have 32 as our common denominator. So we'll get 16 into 32 is 2 times 3 is 6. We have plus the 7/32, again divided by 2. That gives us 13/32 divided by 2, which is the same as 13/32 times 1/2, which is 13/64. And that is answer choice K. That's the number right in between 3/16 and 7/32. 25 is the circle that has a center of -3, 4 and is tangent to the y-axis. Tangent meaning it touches at one point right there at the y-axis. Is graphed in the standard xy coordinate plane. What is the area in square coordinate units of this circle? So let's remind ourselves of the area of a circle is equal to pi r squared. We need to know that. Okay, so when we're finding the area, another thing I'm looking at is in our answer choices, I'm glancing, they make use of pi in the answer. So I don't have to plug in a value for pi, I'll just use that symbol. But I do need to know what the radius of this circle is. And it's important that we know that this is tangent at this point. We know that, meaning that it touches there on the y-axis, that we're going to have an x value of 0 at that point and a y value that's going to be equivalent to what we have at the center, which is 4. That's the point 0, 4. So we can find this radius value here. It goes from 0 to -3. That means we have a radius of 3. R is equal to 3. So I'm going to plug in a 3 squared for my radius, and that is equal to 9 pi, which is answer choice C. 26 tells us that an 8-sided game piece with faces numbered from 1 to 8 is rolled twice. What is the probability that an 8 is rolled both times? We want to roll and get an 8 and then get an 8 a second time. And the note is that assume that each side has an equally likely chance of being rolled. So when I roll an 8, I have an equally likely chance of rolling any value 1 through 8 after that. So we're doing probability again, a part over a whole. So let's look at on the first roll, since there are 8 sides, we have the probability of rolling an 8 to be 1/8, equal probability. And then on the second roll, we have an equal probability of rolling an 8 again. That's 1/8 again. We're going to multiply these two values together, and that just turns out to be 1/64, which is answer choice F. That's the probability of rolling 8 both times. Question 27 says when 3x minus 2 is raised to the fourth power, when it's expanded and the like terms are combined, what is the coefficient of the x to the fourth term? We want to know what value is in front of the x to the fourth. Now, there are different ways that you can memorize raising things to the second power, third power, fourth power, and that's great. I can't always remember them. So to me, it's almost just as easy to expand these out by multiplying. 3x minus 2 to the fourth is the same as just taking 3x minus 2 squared, multiply those together. So I want to look at 3x minus 2 times 3x minus 2. And when I full this out, I get 9x squared minus 6x plus 4. Let's combine like terms, 9x squared minus 12x plus 4. That's what we get when we multiply these together. But remember, we've got two of those, so we're going to multiply this together again. And we're really only concerned with the coefficient in front of the x to the fourth term. When we full this out, we're going to multiply the 9x squared times 9x squared, and we get 81x to the fourth. And then we can do some other multiplying. We get plus and minus. But we're only concerned with what is in front of x to the fourth. And there's no other terms that will multiply together and get an x to the fourth. So we turn out to have 81 as our coefficient we're concerned with. And that's answer choice E. This is another example of one of those problems. You did not have to expand this all the way out because we're only concerned with x to the fourth. If they had asked us for the x to the third term, we would have had to have done a little more. But again, we wouldn't have had to go all the way out. You just work to as far as you need to answer the question. Question 28 says, Bo and Tia will balance perfectly on the seesaw shown below if W1 times D1 equals W2 times D2, where we're given that W1 and D1 are the weight of Bo and his distance from the fulcrum, respectively. And this is our fulcrum here. We're given it's labeled. And W2 and D2 are similarly defined for Tia. Bo weighs 60 pounds and is sitting 3.5 feet from the fulcrum. Tia weighs 2/3 of Bo's weight. What distance in feet, and we want to look at our units, are we in feet? We're in feet. From the fulcrum must Tia sit in order for Bo and Tia to balance perfectly. So we want to make use of this formula, W1 D1 equals W2 D2. And we're given the values for Bo. We know that his weight is 60 pounds and he is 3.5 feet from the fulcrum. And we know that Tia weighs 2/3 of Bo's weight. So we're going to have to take 2/3 of 60, but we don't know this value for D2. That's what we're looking for. So we need to do some multiplying, and then we'll divide here. And we put this in our calculator. We get that this is 210 is equal to, I'm going to do some simplifying there, 40 D2, divide through by 40, and we're going to get that D2 is equal to 5.25. Our answers are in fractions, and we know that the 0.25 gives us 1/4, so D2 is equal to 5 1/4, which is answer choice H. Question 29 says that given this equation, what's the value of 9x minus 2? So let's take a look at this and distribute it out, and then we can see about finding out what 9x minus 2 is. I'm going to distribute this 3. We get 3x minus 6 is equal to 6x minus 3. I want to solve for x. So I'm going to negative 6x equals 3x minus 3. Add 3 to both sides. A negative 3 equals 3x. So x is going to be equal to negative 1. Now we're ultimately looking for 9x minus 2. So I need to substitute in this negative 1 for x, and I get a negative 9 minus 2 is negative 11, which is answer choice B. Question 30 says that Allie is planting flowers around her square patio. The region she is planting is a 1 foot wide strip that runs along 3 sides of her 5 by 5 foot patio, as shown below. What is the area in square feet of the shaded region where Allie is planting flowers? And I want to make sure my units are good. We are in feet for everything. Okay, so we're looking for area of this area that we're planting in, which is right here, the shaded region. And what really this is, when we're looking at it, it's an irregular figure composed of rectangular pieces. We can take this, and you can divide this up in different ways, but I'm going to look at the first piece here, and this is given by a 1 by 5. This dimension here is a 1 by 5, so I can take the area of that, which is 1 by 5, and I'm going to add to that this area over here, which is also a 1 by 5. And we'll add to that this bottom section, or 1 foot here, and then it's also, we've got the dimension across here is 5, but then we have this edge here of 1 and here of 1, so it's really 5 plus 1 plus 1, which is 7. So that is a 1 by 7 piece there. So we're going to do our multiplying and our adding, and we get a total area of 17, which is answer choice J. Question 31 tells us to consider 3 circles, A, B, and C. And we're told some information about the radii of circles A and B. Their sum is 5. And the sum of the radii of circle A and C is 8. And the sum of the radii of circle B and C is 7. And what is the length in meters? We're all in meters, we're good. What is the length of the radius of circle C? So we're looking for this unknown radius circle C. So we've got this information above. We need to write some relationships. We know that A plus B, the radii, are equal to 5. And then we have A plus C, they tell us, is equal to 8. And that B plus C is equal to 7. And ultimately, we're looking for circle C. So we've got to see how to figure this out. So we have 3 equations and 3 unknowns. You can solve this problem by substitution, or you can use elimination. Those would be the 2 methods I would look at. What I'm going to do right here, I think, is do some substitution. I'm going to try to get C into this last expression here. And I'm going to start here, and I'm going to solve for A. And we know that A is equal to 8 minus C. And then I'm going to plug that into our first equation. In place of A, I'm going to put 8 minus C plus B is equal to 5. And I'm going to solve for B. And I know that B is equal to, when we subtract 8 from both sides, we get a negative 3 plus C. So now I'm going to take this expression for B, and I'm going to plug it in to our third equation. And I have a negative 3 plus C equals 7. So 2C is equal to, add 3 to both sides, 10. Divide through by 2, C is equal to 5, and that is answer choice E. Question 32 asks us, what is the complex conjugate of the number below 2 plus 3i? So we need to remind ourselves what this means, complex conjugate. The conjugate of a number means we're going to take this number, the 2 plus 3i, and the conjugate means just to change the sign between the real number and the imaginary component, making it 2 minus 3i, and that is going to be answer choice J. It is a complex conjugate because we are composed of both a real number, the 2, and the imaginary number 3i. Question 33, the function p of x equals x cubed minus 10x squared plus 9x minus 90, where x is the number of items sold, models the profit p of x in dollars for company A. The company breaks even when the profit is $0. How many items must company A sell to break even? So we want to find what is this x value when the profit is equal to 0. So that's basically what we're going to do. X to the third minus 10x squared plus 9x minus 90. We're going to break even when it's set equal to 0. And so when we have this expression here with an x to the third, we have to think of some of the things that we've done to be able to solve an expression like this. And the first thing that comes to my mind that I might want to try is maybe a factor by grouping. I'm going to take these first 2 terms and then the last 2 terms and group them together. We're going to look and see, what can I pull out? I can pull out an x squared from here, and I have an x minus 10 remaining. And then on the last 2 terms, let's pull out a 9, and we have an x minus 10 equals 0. So this is exactly how I wanted it to work, because now I can combine these into the x squared plus 9 times x minus 10. We rewrite that, set it equal to 0. and then we set each of the terms equal to 0, x squared plus 9 equals 0, that's going to give us a negative number with the square root, and that's not going to work for our answer. And we said x minus 10 equal to 0, x is going to be 10. And that's the value we're going to be looking for with answer choice D. That's going to be how many items to sell to break even. Question 34 asks us, which of the following statements shows that any subtraction can be written instead as an addition? So this is a which question. That means we are for sure going to have to evaluate our choices to come up with the answer. And so it's telling us that we want to have a statement that shows that subtraction, which is what each of our values on the left-hand side of the equal sign in our answer, that it can be written as an addition. And each one of these on the right-hand side are addition statements, but we've got to see which ones are true statements. So let's take a look at the first answer choice. We're just going to have to go through each one, and we'll just start with F here. When we take the absolute value of A, we're just going to turn out with a positive A value. Plus, when we take the absolute value of negative B, we're still going to have a B value, a positive B value. So that tells us A minus B equals to A plus B. No, that is not the same. Now let's evaluate G option. The absolute value of a negative A gives us A, plus the absolute value of B gives us B. Well, that's the same as in the F choice, so G is not correct. Take a look at option H. We have on the right-hand side, we have A, still A, plus the absolute value of negative B is still going to give us B. That's the same thing as our first three options. Now let's look at J option. We have A still plus a negative B that we just rewrite this as, I should have written it right here, A minus B. We can have a plus to a minus, gives us a minus. And so that tells us that A minus B equals A minus B. So that is the one we're looking for. Option J is going to be our answer. Let's just evaluate for fun, K. Once you got the correct answer, if you're working through the test, you would stop at this point. But when we have a negative A in parentheses, we can drop the parentheses and we just have a negative A plus B. Let's rewrite that with the positive value in front. It's the same as B minus A, which is not the same as A minus B, what we have on the left-hand side. So that's why K is not an answer. Number 35, we've got to evaluate a square root and a cube root. We're looking for the value. So we have the square root of 9/4 minus the cube root of negative 1/8. And when we take the square root of a fraction, it's the same as taking the square root of the numerator and the square root of the denominator. And we can do the same thing for the cube root if you need to do that. And we'll do the cube root of 8. Now the square root of 9 is just 3, and the square root of 4 is 2. So we have 3/2 minus the cube root of negative 1. Now remember, we can handle negative numbers when we have cube root or any odd number root, because just as a reminder, if we had 3 negative 1s that we're multiplying together, negative 1 times negative 1 is a positive 1, times negative 1 is a negative 1. And so that's where we come up with the cube root of negative 1 to be negative 1. And then the cube root of 8 is 2. 2 times 2 times 2 is 8. So we have 3/2 minus a negative 1/2. So that's really the same as 3/2 plus 1/2, which is 4/2, and which is 2. And so that is answer choice E. Question 36 says, given f of x and h of x, what is h of f of x? So we're given two function values, and we're going to find the composite here. So that's the same as taking h of, instead of f of x, I'm going to plug in negative x minus 4. And now it tells us take h, and everywhere there's an x, we're going to stick negative x minus 4. So 2 times negative x minus 4 plus 3. And then we're just going to simplify, distribute the 2 through here. We get a negative 2x minus 8 plus 3. That's equal to negative 2x minus 5, which is answer choice F. For question 37, we're told that rectangle JKLM is shown below. It is a rectangle. We know we have right angles. The given side lengths are in feet, and what is the cosine of angle KJL? So angle KJL, we're talking about this angle right here, and we're looking for cosine, I'm going to say of x, that's my angle KJL, and by definition we know that cosine is equal to adjacent over hypotenuse. So relative to angle x, our adjacent side length is 9. So we can go ahead and plug in 9. And then our hypotenuse is opposite the right angle, and we don't know what that value is. We have two side lengths, and we can find the third of a right triangle using the Pythagorean theorem. So we have a 7 squared plus 9 squared equals, we're going to label this hypotenuse y squared. So we have 49 plus 81 equals y squared, and that is 130 equals y squared. And so we can find the square root of 130 to be the value of y. And I'm glancing at my answer choices, and I see some of them make use of square root of 130. So that's a clue that we're probably not going to be able to simplify that square root of 130. I'm going to keep that as my denominator, the hypotenuse, square root of 130. And do we have an option for 9 over the square root of 130? We do, and that's answer choice D. Question 38 says that the first 3 elements of a pattern are shown below. Each element is composed of small squares that are 18 inches wide and 18 inches in length. Each element after the first is a square that is 18 inches wider. So basically we have 18 inches there, 18 inches there, which gives us a total of 36, and then the same thing on the width there. The length and the width are the same. What is the area in square feet of the fourth unit? So notice again, we're in inches up here, and we're asked for an answer in feet. So we're going to have some unit conversion that we need to do. So I want to make sure I remember that as I'm working through the problem. We're asked for the area of the fourth element, and we're talking about an area of a square, and if we remember, the area of a square is equal to the side squared. We're given the first rectangle here, the second here, the third, and then how do we know what the fourth looks like? Well, we're increasing each side length by 18 as we go. So if the second was a 36 by 36, the third element is going to be a 36 plus 18, which is 54, so a 54 by 54. The fourth one is going to have 54 plus 18, which is a 72. So we have a 72 by 72 for our fourth element, fourth square. So we can find, and this is in inches also, 72 inches. So we can take 72 inches squared, and that's going to give us a value in inches squared. But we want our answer in square feet, so we know that there are 12 inches in 1 foot, but we have to square this so that we can have our inches squared to cancel. So now we have 72 squared divided by 144, and I'm getting this 144 from the 12 squared. Put that in our calculator and we get 36 square feet, which is answer choice K, the area of that fourth element. 39 gives us an operation that is this x with a circle around it to be defined on the set of positive integers by the rule a with this operation b is equal to a plus b squared. This is our rule that we are to follow to find the value here of 4 operation 3 operation 5, and we want to pay attention to our parentheses here. So first we've got to find what this is with this 4 operation 3, and again we're using this definition that tells us a and b. In our case, a and b are 4 and 3, so we're going to define this as a, which is 4, plus b squared, which is 3 squared. So that's the same as 4 plus 9, which equals 13. Now let's go back to our original question here. We know that 4 operation 3 is 13, and then we do our operation 5. Now our A is 13 and B is 5, so we have that equal using our rule to 13 plus 5 squared, which is 13 plus 25, and that equals 38, which is answer choice B. Question 40 says the number A is a positive integer greater than 1, and the number B is a negative integer. What is the number A to the B power? So we've got to look at these different options that we have that our result could be, but let's look at how we've defined A and B again. So A is a positive integer greater than 1. So A is an integer greater than 1, and B is a negative integer. So B is going to be less than or equal to -1 is how we could look at that, because it is an integer. Integer meaning it's not going to have a decimal point. And so really we could even say that A is going to be greater than or equal to 2. That's going to be the first value that A can be. So let's look at what happens. And we can solve this in different ways, but it may be easier to just use some example points. Let's say, what if a valid value for A, let's say A is 3 and B is going to be, we'll say -2. So A to the B power, given those definitions, A being 3 and B to the -2, we rewrite anything with a negative exponent as a fraction. That's the same as 1 over 3 squared, which equals 1 over 9. So that is our result. This is a valid result. It is not a special case. That's the other thing we need to be sure of when we come up with example values, that we're not looking at a special case. But for any value that is raised to a negative power, we know that it's going to have to be flipped and made into a fraction to have that positive exponent now. So looking at our options, is that number 0? No, it is not 0. Is it positive? Well, yes, it is positive. Let's make sure that's the only thing. Is it negative? No. Having the negative integer for B, that only makes it a fraction, so it is not negative. Irrational, what does that mean? It's almost easier to me to think about, well, what does rational mean? Rational means that you can write something as a fraction. We can write something as a fraction, okay? And even numbers like 3. 3 is a rational number because I can rewrite that as 3 over 1 as a fraction. So it doesn't have to be like 1/3 as a fraction, which is a rational number. Irrational meaning it can't be written as a fraction, and we got a fraction, so J's out. And is it an integer? No, it's not going to be an integer because of this negative exponent means we make it a fraction 1 over. So the only valid answer is G, that it is positive. Questions 41 through 43 are going to make use of this information in this paragraph and this chart. A lot of times when I'm beginning a question like this, I almost go on down to the question and read it and see what information I need. So let's look at the question. It says, according to the mileage reading, so we're talking about some mileage in this chart, what distance in miles did the truck travel on June 20th? So we're talking about June 20th, and I see mileage out, mileage in. That might be some information I need to make sure I know, because I'm looking at this value, 989 and 245. It doesn't really look clear of what I'm doing, so I may have to go up here and read some. And I say that this is a part of a delivery truck log. Mileage out and mileage in represent the truck's mileage reading when it leaves the office, okay, so at the beginning of the day maybe, and then when it returns to the office respectively. So this is when mileage out when they leave, and when they come back in on return is the mileage in. But then how do these values, I still have not gotten one of my questions answered, that we went from 989 to 245. It says these values are given only the last 3 digits of the cumulative mileage reading. Okay, so what that means is that if these numbers, these are only the hundreds place. We're not listing like the thousands. Like this truck may have actually gone, if we look at June 20th, 10,989. This is just a value I'm putting in. It could be any value here, but then it rolled over to the next 1,000 to 11,245. This is the value that's in our chart, 989 and 245. These are the values that roll over. So on June 20th, what we need to look at as we went from 989 to the next 1,000th place is 11 miles. And then it rolled over and went 245 more miles, which gives us a grand total for the day of 256. So that's answer choice E. That truck on June 20th traveled 256 miles. Question 42 gives us a figure here shown below that represents the route traveled on July 16th. So July 16th is not even in this chart. Aaron started at the office, so we're right here, drove 75 miles due north, that's shown in the graph, to the first stop, then 45 miles due east. We have a right angle right here, due east to the second stop, and then 105 miles due south, another right angle, to the last stop. On his return trip home, he drove a straight road from the last stop to the office, so this is not a right angle right here. Which of the following, given that Aaron drove at the truck's average speed, which we don't know that, but I'm going to guess it's in the information above, which of the following values is closest to the time in hours he drove on the return trip? So we don't know how far the distance is from the last stop to the office, but let's look at this truck's average speed. Let's go up here in our paragraph, and we had read up to almost the last couple of sentences. When moving, the truck travels at an average speed, here we go, of 50 miles per hour. 50 miles per hour. So that is our average speed, 50 miles per hour. But we need to know we're asked for the closest time in hours that he traveled. So if we know he goes 50 miles per hour, if we know how many miles he travels, we can figure out our time. How can we do that? So we have several values on here that we can use. But when I'm looking at this graph, if I want to find this unknown distance that we have circled here, we could draw a line perpendicular to the line that represents from the second stop to the last stop. That will give us a 90 degrees right here. And we know a couple of these other values. We know that this distance, straight line distance, is 40. And we get that from the distance here from the first to second. Those lines are both parallel. And we can find the distance of this leg. We know that the total from the second stop to the last stop was 105. And we'll subtract out from that 75, the line parallel from the office to the first stop. That's going to give us this distance here, and that's going to be 30. So we know we have a distance of 30, 40 here. That would make, this is our hypotenuse. If we can recognize, we have a 3, 4, 5 triangle right here with a multiple of 10. So we went 30, 40, that would make the distance traveled from the last stop to the office of 50. We don't even have to use the Pythagorean theorem. We could if we need it, but that distance is 50. So he traveled 50 miles at 50 miles per hour. So we're going to multiply by 1 over 50 miles per hour. So we'll get the hours in the numerator now. We'll get those to cancel. 50 over 50 turns out to be nice and even 1. So he traveled 1 hour on that last stop to the office. Question 43, which still goes with this graph, we may have to flip over. From June 17th through June 21st, the average of the hours away was 5.5. That's our average, 5.5 hours. To the nearest 0.01, what is the value of hours away when Ben was driving the truck? So let's look at our chart. And when Ben was driving our hours away, we don't know this value, but we know the average of these 5 was 5.5. So what we can do is we can take the values, the 4 that were given, using the average that were known, we can figure out this unknown. So we were given up above that 5 hours plus 5.5 plus 6.0 plus that fourth value was 5.75. And we have the unknown for Ben, we'll say plus B. That divided by 5, there's 5 values, is equal to this average of 5.5. So we're wanting to solve for the unknown B. We can add these values we get 22.25. I'm going to multiply both sides by 5, and I get 27.5 is equal to 22.25 plus b. I want to solve for b, so I'm going to subtract this 22.25, and I get that b is equal to 5.25, which is answer choice A. That's how many hours away Ben had on his particular day. Question 44 says, in triangle ABC shown below, the given side lengths are in meters. What is the area in square meters of triangle ABC? So this is our second area of a triangle that we've been asked to find. We have area is equal to 1/2 base times height, and I like using this for my base if I can, but I need to know what this h value is. So I'm going to go ahead and plug in what I know, a base of 8. And then we need to know this h. But we have a 60-degree angle here. This is a 90-degree. If this is 60, we have a 30-degree. So this is a 30, 60, 90 triangle. And we should know the relationships with a 30, 60, 90 triangle. If this one is 30 and this is 60, and we know that the length opposite the 30 is x, the hypotenuse is equal to 2x, and the leg opposite the 60 is going to be x on the square root of 3. So we can use this relationship here and apply it to the triangle that we have here. We don't know what this length is right off. We know our hypotenuse is 6. If the hypotenuse is 6, then we know that the angle opposite the 30 is 3. We don't really have to have that information, but it's half. But that helps us to find this length of the leg opposite the 60, which is equal to 3 on the square root of 3. And so we can plug that in for our height, 3 on the square root of 3, and we'll do some simplifying here, and we get the area is equal to 12 on the square root of 3, which is answer choice J. 45 gives us values for log of x, and we're asked to find to the nearest 0.1 the value of log of 3 times 10 to the 5,000ths. And you might think, oh, I can just plug this in my calculator, where you're going to find that you're not able to put that in. So we're going to make use of our chart. And let's see, anytime I have a problem like this, I'm going to see if I can find a pattern. There's something in the data that they're giving us. So in the question that we're given, we have a number in scientific notation. So let's see if there's any kind of relation if we have our x values, if we put them in scientific notation, if we can find a pattern. So I can rewrite 3 in scientific notation as 3 times 10 to the 0 power. Remember, anything raised to the 0 power is 1. 2 to the 0 is 1. 10 to the 0 is 1. 1,000 to the 0 power is 1. Remember that. So we'll have 3 times 10 to the 0. I can rewrite 30 as 3 times 10 to the first, rewrite 300 as 3 times 10 squared, 3,000 as 3 times 10 to the third. How do we see a pattern yet? Well, if you'll notice what we wrote, what the 10 was risen to, corresponds to the value in front of the 0.5. We've got 3 times 10 squared is 2.5. 3 times 10 to the third is 3.5. So it should make sense that 3 times 10 to the 5,000 is equal to 5,000.5. That would match with the pattern, and that is answer choice D. 46 tells us that Susan completed 20 courses in college, and she graduated with a GPA of 3.15. And where an A is worth 4 points, B is worth 3 points, if all her grades were A's or B's and each course grade carried equal weight, what's the number of A's that Susan received? That's what we're looking for, of the 20 courses. So we can set up a couple of relationships here. We know that if we represent A and B to be the number of A's and then the number of B's, she had A's or B's in all 20 courses. So the number of A's plus the number of B's is going to equal 20. And we know that the A's counted 4 points plus the B's counted 3 points. When we divide that through by the number of courses she took, That's what gives us the GPA of 3.15, the total over the number of classes she took. So we have two equations and two unknowns, and we can do some solving. So let's rewrite this second one as 4a plus 3b. I'm going to multiply through by 20, and I get 63. So now I have equations that look good. Let's solve this one. We're wanting to ultimately know how many a's. So let's solve for b here, and we get that b is equal to 20 minus a. And the reason I'm going to do that is I'm going to plug in down here in place of b 20 minus a. And there's multiple different ways you can do this, but this is the method I chose. I'm going to distribute the 3 through. Minus 3a equals 63. And then we get 4a minus 3a, that gives us a. Subtract 60 from both sides. We got that Susan had 3 a's. That's answer choice G. Question 47 says that the right semicircular cylinder shown below has a height of 5 centimeters and a semicircular base of radius 3 centimeters. What is the volume in cubic centimeters? Our units look good. We're in centimeters here and centimeters here. What is the volume of the right semicircular cylinder? So we're having to find the volume of a cylinder, which is equal to pi r squared h. And this is a formula you need to be familiar with, and you can use that. But we're also needing to look at that this is a semicircular cylinder, and the cylinder, it's only half of that. So for our particular case, we're going to look for 1/2 pi r squared h. And this question really is nice. If we can get the formula, then we are given all the values we can plug in here. So also notice in our answer choices, we've got pi in our answer. We're going to leave this pi here, not plug it in. What's our r value? Well, they told us that that is the 3, so we're going to make sure we square that, times our height, which is 5. Let's simplify pi, and then we have 9 times 5. So that's equal to 45 over 2 pi, and that's the form our answer is in. That is answer choice B. 48 says, for positive real numbers m and n, what is the log of m over n equal to? This is going to be making use of our properties of logs. We're expanding this out where we had log of m over n. You should be familiar with this property when we expand it out. This is the same as the log of m minus the log of n. That is a property, and that turns out to be answer choice J. So be familiar with your properties of logs, expanding them and condensing them. We have logs with multiplication. We need to know how to do that, and also raising those to a power. So make sure you take a look at those different properties. Question 49 says, for what real number b, if any, will the equation a minus 2b plus ab equal 2 be true for both a equals 1 and a equals negative 1? Well, it looks like we need to try these both cases, plug in these different values for a. When a is equal to 1, we're going to have 1 minus 2b plus, plugging in 1, b equals 2. Combine like terms, minus b equals 1. So b is equal to negative 1. Now what happens when a is equal to negative 1? We're going to have a negative 1 minus 2b minus b equals 2. Combine like terms, minus 3b equals, add 1 to both sides, 3. b is equal to negative 1. We have the same value here, so it looks like our value for b is b, negative 1. Question 50 through 52 is going to make use of this information in this table. Let's go ahead and just look at the question for number 50. It says, Terry will hang one dress of each style along a rod in the window of her store. How many total possible orders, permutations, we see the word permutation, of these dresses are there for Terry to consider? So we're given that this is a permutation. We have a rod here. She's going to hang 5 different styles of dresses on this rack, on this rod, and we want to know how many different orders could she arrange this. If We're given, it looks like in the information in the table above, we have styles A, B, C, D, E. Well, she could also go A, C, B, D, E, or she could go A, C, B, E, D. There's lots of different ones to consider. And that's our question. How many different ways can she order these dresses on the rod? Permutation, remember in permutation, position matters. We're talking about specific order, and they tell us that. If they had not told us that, we would have to determine, is this a permutation question or a combination? And because order is mattering, it's permutation. So there's 5 dresses. So we're looking at a permutation of 5 total options, and we're picking and ordering all 5. So you could plug this into your calculator as a permutation of 5, take 5, or this reduces down to 5 factorial, which turns out to be 5 times 4 times 3 times 2 times 1, which is 120. Again, you could plug this straight into your calculator and find that if you understand it, or if you understand more, to do a 5 factorial. That is answer choice J, 120. Question 51 says Terry's going to offer a coupon in the local newspaper for 20% off the regular price of a dress. What is the regular price Terry must set for style B so that the sale price using the coupon is exactly $15 more than the cost of producing one? So if we go back, we need to use some information from above, because what is the cost of producing one? And we read right here, production costs, we're looking for style B. It's got to be $15 more than this 25. So 25 plus 15 tells us that $40 is how much she wants for the sale price. So if the sale price is $40 at a 20% discount, what is the regular price? That's what we're looking for. So we know that 40 is 20% off of the full. Or another way to say that is 80% of the full price, the regular price of the dress. So I'm going to find the full price, the regular price, by dividing 40 by 0.8, and we should get that X is equal to $50, and that is answer choice D. That's the regular price of style B dress. Question 52 says that the labor cost of each dress is 40% of the production cost. What is the average labor cost per dress for one dress of each of the 5 styles? Okay, so we can go back up here. We again need to make use of this production cost of each dress, and we're told that that is 40%, the labor cost is. So 40% of the 15 plus 25 plus 45 plus 60 plus 65, that's going to give us the total labor cost of all 5 styles, but I want an average, so I'm going to divide by 5, and when I put that into my calculator, I get the average labor cost to be $16.80, which is answer choice F. Question 53, we're back to not using that chart, we're on our own. It took 0.5 seconds for an object to travel 60.5 feet. To the nearest 0.1 mile per hour, what was the speed of the object? And we're given this special note that 1 mile equals 5,280 feet. Clue. We're given answers in second and feet, and we're asked for an answer in miles per hour. So we're going to have to make use of this conversion factor. So we're looking for speed, and speed is going to be distance over time. So we have 60.5 feet over 0.5 seconds. Let's make use of some of our conversions. Not only do we have to convert feet, we also have to do our time, because we want in hours, and we know that 60 seconds is 1 minute and 60 minutes is 1 hour. We want to line this up so we can cancel out the units we don't like, and we want to be left in per hour, so I've got that way. Now let's do our distance. We are told that 1 mile equals 5,280 feet, and that way we can set it up this way to get our feet to cancel. We'll plug each of these numbers into our calculator, and you should get 82.5 miles per hour. And that is answer choice C. Conversions are very important in this problem. Question 54 gives us representatives of vectors u, v, p, q, and r are shown in the standard coordinate plane below. One of the following vectors is equal to the vector u plus v. Which one? So we're going to add together the vectors u plus v. And don't be concerned, don't be scared of a question about vectors. These are defined here. A vector shows magnitude and direction, and let's see what we can take a look at here. So we have the vector u, which we're talking about this one, and the vector v, and we're going to add these up. Now, we can look at defining the terms that represent u and v, and then figuring out which one of the other vectors that are given as the answer choice does that, but I think we can answer this question just by a visual inspection. If you look at u, that is going in an upward direction here. It's going in a northeasterly direction. Think of the v vector going as the southeasterly direction. And when we add those, we're going to bring each of these, bring the u vector down a little bit. V's going to come up a little bit to combine. And so we're going to have more of a vector that comes together sort of like this. And that corresponds to very similarly what we would find in vector q. And so q, of all these options, that's the closest one that's going to look like that. And that's answer choice K. Answering this question visually is going to get you to the correct answer. Question 55 says, in the standard xy coordinate plane below, a shaded square is shown with the vertices 2, 3, 2, 4, 3, 3, and 3, 4. Two lines y equals rx and y equals sx each intersect the shaded square at exactly one point. Given that r is not equal to s, what is the positive difference of r and s? So r and s are not the same thing, but when we look at y equals rx and y equals sx, these are both lines. And we know that r and s are not the same. We know something about them from our form y equals mx plus b. We know m is our slope, so r is the slope of this line, s is the slope of this line. We have this plus b, which is the y-intercept. And in our case, it's plus 0. So what that means is both of these lines are going to cross the y-axis at the origin. The only place that these two lines can intersect the shaded area at exactly one point. We could not have it go through there because that intersects at infinitely many points. So that's not going to be our answer. But the only point would be at one of these vertices, here or here. It can't cross it this vertice or that vertice because, again, it's going through infinitely many points. It would have to cross in the middle. So that gives us these as the only two options. And because we know that r is not equal to s, we know it's going to be one in this case and one in that case, not the same. So when they cross, one's going to cross through here. So this line crosses through here. Now our second line, which is going to intersect at this vertice, will cross through the origin and it will cross through that point, and that's our second line. So when we take a look at each of these points, we need to know, if we could find out what the slope is of each of these lines. One of these is y equals rx and the other is y equals sx. So let's just take a look at this particular line right here. Remember, when we're talking about slope, it's the change in y over the change in x, or it's the rise over the run. And we could look at points if we wanted to, or let's look at this graphically. When we're starting here at the origin, we're going to rise up 3 and run over 3. So that turns out to be 3 over 3, which equals 1. So this particular line has a slope of 1. Now what about this line? We're going to rise up 4 and run 2, which is a 4 over 2, which equals 2. That has a slope of 2. So our question asks for the difference in r and s, those slopes. So our absolute value difference is 2 minus 1, which equals 1. And that is answer choice E. Question 56, they say a random number generator that generates an integer 1 through 6 will be used 15,000 times. Each time an integer is generated, the number will be recorded. Which of the following descriptors will most likely characterize the distribution of the 15,000 recorded numbers? So this is a statistical question. We need to have some knowledge of these statistical terms that are in our answer choices. And when we take a look at these, even if you're not 100% sure on statistics, hopefully you can get some information that maybe you can eliminate some of these choices, use some of your prior knowledge just about some of the words. And what first jumps out to me is when I see H and G, that these are skewed left or skewed right. And I don't really feel like that would have anything to do with getting these values, this random number generator, skewing left and skewing right. So I'm going to eliminate those options. And when we look at bimodal, the bi here has something to do with 2 being bi. And when we look at some kind of normal distribution, which is with G, we think of that bell curve. And that really doesn't have anything to do with describing the distribution, how we've recorded the numbers. A bimodal distribution is going to have 2 modes, and we have no indication of that in any of our wording. So F is going to be eliminated. We said G had to do with a normal distribution itself. The one that's going to turn out to be our answer is K, uniform. And uniform means that each outcome, there's an equal likely probability of the outcome. And that's what we have described here with the random number generator that's going to produce an equal likely integer of 1 through 6 to be generated at a time. And so our answer choice, the best one would be K. In the standard XY coordinate plane, define the HV distance between 2 points to be the length in coordinate units of the shortest path between the 2 points using only horizontal and vertical segments. So the expression absolute value of 5 minus 2 plus the absolute value of 3 minus a negative 4 gives the HV distance between which of the following pairs of points. So when we're reading this, we see this in italics, HV distance, and we may initially think, I don't know what this is. But the thing is, within this question, they define what HV distance is. We're looking at the shortest path between 2 points using horizontal and vertical segments. So that's the definition. And then they give us an example here of finding that HV distance, and they want to know between which pairs. So based on this absolute value of 5 minus 2, that's going to be the shortest distance either in the horizontal or the vertical distance. We're not for sure yet. And we're going to add to that this absolute value of 3 minus a negative 4. And that's either, if this is horizontal, then this is going to be the vertical. If this is the vertical on the left, this is going to be the horizontal. So we've got to see which one this would match up with. So if we look at our points, with the first one that we're given is 3, 5. So when we're looking at horizontal distance, that's going to be of the x values. So we would have an x value here, we'll say x1, and then this is the x value 2. So do we have the case where we're subtracting 3 minus a negative 4? Well, we actually do right here, 3 minus a negative 4, and then our y values, y1 and y2, 5 minus 2. And as it turns out, here's our 5 minus 2. So this is the difference in the vertical and then the horizontal. So this is going to be, as it looked up first, answer choice A is the point 3, 5 and negative 4, 2. And this is the expression that you would use to find the horizontal, the HV distance. Question 58 says, let M and S be the mean and standard deviation, respectively, of the ages of children in a certain daycare center. Which of the following gives the mean and standard deviation of the ages of the same children 5 years later? So let's think about this. We're having to look at how these values, mean and standard deviation, are going to change in 5 years. Let's just say, for example, the mean that we begin with, the mean of the children is 10. Well, 5 years later, each one of those children are going to be 5 years older, so that's going to make the new mean 5 years more to 15. So what did we do? We added 5 to the mean. So That means we're going to change our mean. We're going to increase it by 5. So F and G are out because H, J, and K are the only ones with M plus 5. Now, what about the standard deviation? Let's say the standard deviation is 0.4 because we're talking about age and in years. So maybe some of these in the following daycare center may be in the same class and they're within a year of one another. 5 years from that initial standard deviation, are they still going to be within a few months of one another? They are. So the standard deviation is not going to change. Their ages have changed, but the difference between each of those did not. So our standard deviation stays the same, and that is answer choice H. Question 59 says the ellipse in the standard XY coordinate plane below is the graph of, and they give us this equation, which of the following points are the foci of the ellipse? So we are given an equation here for the ellipse. What we need to be concerned with on the foci, since they give us options, we will want to try to make use of those answer choices and not actually maybe have to calculate what this is. We can calculate it with a formula, but we're trying to do this quickly. In general, we know I'm going to eyeball. This would be the center of my ellipse, and my foci are going to be around this. They're on the major axis, and they're within the ellipse curve itself. So let's take a look at the points and see if we can eliminate some of these before we have to do any calculating. So answer choice A is the point 0, 3, and that's the point right here. That's a point on the major axis of the ellipse. That is not where we would find the focus. So A is out. B is going to be out because it has 0, 3 as well. C has the option 1, 3, and that's going to be about right here. And 5, 0. 1, 2, 3, 4, 5, 0. That's this point right here. That's not where you would find the focus. But 1, 3 is a possibility. So we're going to look at D with 1, 3 and 9, 3, which gives us the point right here. That could very well be an option for the focus, D. Let's just confirm with E, we have the point 5, 0 again, which is this point. E is out. D is the only option that makes sense for the answer. Question 60 says Lucinda ran a 3-mile cross-country course in 24 minutes, while Franny ran the same course in 21 minutes. Which of the following values in miles per hour? Notice that's in italics. We've got minutes up here. We're going to have a unit conversion issue. Which of the following values is closest to the difference between Franny's average speed and Lucinda's average speed? So it seems like we did another problem previously with speed, and remember, speed is distance over time. And let's first look at Lucinda's. Both of them ran 3 miles, but Lucinda went in 24 minutes. And we need, this is in miles per minute, we need to be in miles per hour. So we know there are 60 minutes in 1 hour, and we can do this conversion. We'll do the calculation for Lucinda, and she is at 7.5 miles per hour. Now for Franny, she's also going 3 miles, but her time is in 21 minutes. And we need to do the conversion of 60 minutes in 1 hour. And when we do that calculation, we're going to come up with 5714 miles per hour. I'm going to keep this value in my calculator and then subtract because we're looking for the difference. And when we subtract these in our calculator, we're going to get approximately 1.071 miles per hour difference. And we're saying closest, looking at our values, we're to 1 decimal point. This is going to round to 1.1, and that is answer choice H. Conversion is very important in this problem. That completes the April 2021 test. If you have any questions on any of these particular topics, again, I would encourage you to take a look at the other videos I have on my YouTube channel where I go through a lot of these individual topics and give you a review of those. Hopefully that will prepare you for similar types of questions as this and others that you may see that have to do with these different math topics. You can get more resources also on my website, teachmathwithme.com.